Notes 8.1, Understanding the Value of a Logarithm. In this first video here in pre-calculus, we're just going to be looking at what is a logarithm. The expression log base b of a, which is red, log base b of a, and a, which is called the argument, has to be larger than 0. It means it has to be positive. And b has to also be positive, but it can't be 1. It's called the base. This whole thing is equivalent to an exponent. The logarithm is the exponent. Let's try to make some more sense about this looking at logarithmic form versus exponential form. Exponential form, if we had something, a base raised to an exponent, it's going to equal this number x. Put this in log form, we have log with the same base. The argument was the item that was by itself over here in exponential form. And this whole thing is equal to the exponent, because if you put this in exponential form, that's where the exponent was. Now I will admit, the way this is written in log form is completely illogical. I wish it was written different, but it isn't. We need to be proficient at changing something from log form to exponential form, or from exponential form to log form. Notice once again, the base has to be bigger than 0, but it can't be 1. And the argument, which is this fellow here, has to be positive. So just some quick examples. Change each log form equation to exponential form. So this one here would be the base of 2 raised to the exponent equals the argument. Number 2 over here to the right, you take the base raised to the exponent equals the argument. Let's just make a note here. This is the base. This is the exponent. And this is the argument. Let's do number 3 also. We take the base of 3 raised to the exponent of 1/5, and that is equal to, I should have been color coding this the whole time, the argument. Please pause the video and see if you can do these 3. 1, 2, 3, and then unpause the video and see the answers. So this one would be 36 to the 1/2 equals 6. This one would be 10 to the -6 equals 0.001, 2, 3, 4, 5, 0, 0, 1. And this one would be 5 to the 1/2 equals the square root of 5. Let's just look back through this and look factually if we think each of these things are true. 2 to the 4th is 16. 2 times 2 times 2 times 2 is 16. 3 to the 1/5 is 3 to the 1/5. 10 to the -6, we take the number 1 and move it to the left, the decimal point to the left 6 times, and that gives us this little fella. Here we got 10 to the 3rd is 1,000. 10 times 10 times 10 is 1,000. 36 to the 1/2 means the square root of 36 is 6. And 5 to the 1/2 is equivalent to saying the square root of 5. So those all check out. When you're looking at this right here, let's say that we just had the left side of the equation, we didn't have the right side. This is asking 2 to what exponent is 16? And it's saying the answer is 4. 2 to the 4th is 16. So it's just there's a small overview of logarithmic form and exponential form. It's important to remember that the base has to be positive and it can't be 1, and the argument has to be positive. That concludes the first video.